So eventually, we're going to use matrices, that we started learning the basics of yesterday, to solve complex multivariable systems of equations. So in Algebra 1 and Algebra 2, we solved systems of equations, typically just two equations with two variables, right, x and y. So we'll take that a little bit further, and eventually we'll start using matrices to solve them. All right. So we'll get to three equations with three variables, and even four equations with four variables. All right. But before we jump into all of that, we're just going to take a day to review kind of the basic systems of equations that you did in Algebra 1 and 2. All right. So today should be a very easy day. We won't spend a whole lot of time doing it just because, this is all 100% review. All right, so first, the substitution method. All right, here's a list of the actual steps, step by step, of what you need to do to use the substitution method. But basically, you pick one equation, you solve for one of the variables, and then whatever it's equal to, you plug it in for that variable in the other equation and solve. All right. So again, I'll review. So we'll go ahead and move relatively quickly through here. All right. Also, the graphing method. This is actually the first method that you ever used to solve systems of equations in school. Right. You would just graph both of the lines, and you see where they intersect. All right. A lot of times, especially when you're doing it by hand, this isn't the most efficient way, because unless the intersection is on like a nice, whole numbered point like -3,2 or 1,7, then it's, you're going to have to estimate. However, when you use your calculator, it can be a lot more accurate, especially when doing these if you try it by hand, you have to be very careful about how you graph lines. So that's why substitution and eventually when we get to elimination are typically the best ways to go about it. All right, so first we'll go ahead and look at this example. All right, so solve the following systems of equations. Now, most of you may look at this if you are good at solving systems and say, oh, well, we can use elimination and that's the easiest way, and I 100% agree with that. However, because we just kind of talked about substitution and graphing so far, all right, we'll go ahead and use the substitution method instead. All right, so to solve the substitution method, all you do is pick one equation and solve for one of the variables. It doesn't really matter which one we do here, all right, but you can do either equation, and you can solve for either variable. All right, so I'm going to go ahead and use this first equation up here. All right, and what I'll do is I'll go ahead and solve for y. So all I have to do is subtract x from both sides, and I'll get y equals -x plus 7. All right, and you don't have to solve for y. You just as easily could have solved for x by subtracting y from both sides, and you didn't have to put it in this form either, right? You could have just said 7 minus x. However, we got pretty used to y equals mx plus b, in Algebra 1 and Algebra 2. So just to kind of put it in a form that we were familiar with, that's why I went ahead and did it this way. All right, well, remember in math, whenever two things are equal, they are interchangeable, right? So wherever I see a y, I'm allowed to replace it with -x plus 7. So I'm going to go ahead and do that in this second equation here. So I have x minus, but instead of y, I'm going to replace that with -x plus 7. And then that's still equal to 2. All right, do be mindful that when you substitute things in, especially when you have more than one term, all right, you definitely want to put it in parentheses. All right, so here we're going to need to distribute that negative. All right, so we will get x plus x minus 7 is equal to 2. All right, so x plus x is 2x. I can add 7 to both sides to get 9. All right, we can divide both sides by 2, of course. All right, so we know that x is equal to 9/2. All right, now do remember that when we are solving a system, we're looking for a point of intersection, essentially, okay? So we need an x and a y. All right, well, luckily I have something right up here that says y equals. All right, well, now that I know what x equals, I can simply plug that in up here. All right, so now I know that y is equal to negative 9/2 plus 7. All right, well, 7 is just 14/2. All right, so negative 9/2 plus 14/2 is 5/2. That's it. We're done. All right, so like I said, just straight review from Algebra 1. Pretty easy. All right, now we'll go to a word problem. I know most people hate word problems, so we'll go ahead and use one of these. So a total of $12,000 is invested in two funds, paying 9% and 11% simple interest. All right, the yearly interest is $1,180. How much is invested at each rate? Okay, so we're going to have to come up with a system of equations, and then we are going to have to solve it. All right, so we have two funds. I'll just call them funds X and fund Y. Okay, so we know that however much we put in one fund plus however much we put in the other fund has to equal $12,000. All right, now we also know that the interest is $1,180. All right, so we know that 0.09 x plus 0.11 y, all right, has to equal 1180. All right, so now all we have to do is solve this equation. All right, so again, we can use substitution here. All right, so the top one is obviously much easier to solve for one of the variables. So we can say, okay, y is equal to negative x plus 12,000. All right, so now, of course, whenever two things are equal, they are interchangeable. So I can go ahead and substitute that down here. So we'll have 0.09x plus 0.11, and instead of y, I can put negative x plus 12,000, and that has to equal 1180. All right, well, now we are going to want to simplify a little bit. So we will have 0.09x plus, and this will actually end up being a minus. This will be minus 0.11x plus, and we'll have to distribute that 0.11 to 12,000, and that'll be 1,320. And that equals 1180. So now combine our like terms here. We're going to get negative 0.02x, subtract 1320 from both sides, and that will be negative $140. All right, so now we divide both sides by negative 0.02, and we will get x is equal to $7,000. All right, so now we know how much was put into the account that was getting 9%, because we just kind of designated that. All right, and of course we can use this one here. Y is equal to negative x, which my x is 7,000, plus 12,000. All right, so y is equal to 5,000. And voila, we are done. All right, so they had 7,000 invested at 9%, 5,000 invested at 11%. Of course, that doesn't really make logical sense in the real world. Why wouldn't you just put all of your money in the account that was giving you better interest? Okay, so here, solving a significantly more difficult one. Still not really that bad. The only thing that we need to remember here is we always want to solve for the linear equation and replace it into the quadratic. It will make our life much easier. So we're going to want to solve for y here. All right, so that's relatively easy enough to do in your head. All right, y is going to equal 2x plus 1. All right, so now we can just go ahead. Of course, when two things are equal, they're interchangeable. So I can substitute this 2x plus 1 into y up here. And when I do that, we're going to get x squared plus 4x minus, and then instead of y, I'm putting in 2x plus 1, and that will equal 7. All right, so we have x squared, and then this will be 4x minus 2x, which will be plus 2x. We have to distribute that negative here, so we have minus 1 equals 7. All right, to solve a quadratic, we actually want to have it set equal to 0. So we're going to want to bring this 7 over here. So x squared plus 2x minus 8 is equal to 0. This will factor to x plus 4 and x minus 2. So when you set each of those equal to 0 and solve, you get x is equal to negative 4 and x is equal to 2. All right, so now we want to plug each of these into y. All right, so when x is equal to negative 4, all right, we will get y is equal to 2 times negative 4 plus 1. So y is equal to negative 7. And when x is equal to 2, we will get y is equal to 2 times 2 plus 1. So y is equal to 5. All right, so essentially, especially when you have more than one solution, it's kind of nice to just write these as an ordered pair. So we know that these two graphs here, this would intersect at negative 4, negative 7, and 2, 5. And voila, we are done. All right, I'll go ahead and kind of skip this example just for time purposes. Okay, so here we have something really crazy, right? This is one that you wouldn't have seen before, right? I doubt that in Algebra 2 they would have had you do systems of equations with a natural logarithm function, all right? But that's fine. We can just use our calculator to do this, all right? So we already have ones. Whenever we use our calculator to do it, because our calculator only allows us to plug things in as y equals, we need to have both equations solved for y, all right? So this one already is, we're good. So over here we can just say, okay, well, y is equal to negative x plus 1, all right? So now what we can do is get out our handy dandy calculator. Alright, and we can go ahead and say y1 is going to equal ln of x, and by 2 will equal negative x plus 1. All right, so when we graph this thing, all right, it's going to look like this. And of course, we can use our intersect function. So we hit second trace to go to our calculate menu. We're obviously looking for an intersection, so we go down here to the fifth option. All right, it asks for the first curve. All right, you just move your cursor there pretty close to where they intersect, hit enter. It asks for the second curve, hit enter again. Guess, you just hit enter again. All right, and our intersection is at 1, 0. All right, so all we have to do here is say okay. We know that this thing will intersect at 1, 0. We're good to go. All right, so calculator can make these very easy. We've already done one word problem. We'll go ahead and skip that one. All right, and we'll get to the elimination method. All right, so the elimination method, basically what you want to do here is manipulate one or both of the equations such that one of the variables, typically usually x or y, all right, have opposite coefficients. Right? That way, when you add them together, that variable will cancel out. Right? Then you'll just be able to solve for the other one. Then you plug it back into either of the original equations, and you're good to go. So we'll look at a couple of examples of that. All right, so here, in this case, we don't have to do any manipulation because the y variable already has opposite coefficients, right? Positive 2 and negative 2 are opposites. So I can actually just go ahead and add these equations together, and I will get 8x. These will cancel. All right, equals 12. So I can divide by 8. And we will get x is equal to 3/2 when reduced. All right. Now to solve for y, all we have to do is pick either of these equations. It doesn't matter which. I'll pick the first one. Sometimes one is easier than the other. In this case, they're both pretty easy, but sometimes you do want to pick one specifically just to make it easier on you. It doesn't really matter, assuming that you're strong enough in algebra, whichever one you pick is going to give you the correct y anyway. So we say, okay, well, 3 times my x, which I know is 3/2, plus 2y is equal to 4, right? So 9/2 plus 2y is equal to, and I'll just go ahead and change that to 8/2. Right, so I subtract 9/2 from both sides. So 2y will equal negative 1/2. Right, and dividing by 2 is the same thing as multiplying by 1/2. All right, so y is going to equal negative 1/4. So our point of intersection would be 3/2, negative 1/4. Now we can look at one where we do have to manipulate, the equations. Sometimes you only have to manipulate one, right? If one of the coefficients is a multiple of the other, then you can just manipulate one. In this case, that's not the case, so we're going to have to do both. It doesn't matter whether you want to eliminate the x or the y. Doesn't matter. I'm going to eliminate the y here solely because one's already a positive and one's already a negative, but it really doesn't matter. You could just multiply, these equations, one of them by a negative to change the x, but I'm going to go ahead and eliminate the y's here. Since I'm doing the y's, I want to find essentially the, the smallest number that is a multiple of both of these, which is going to be 12. So I'm going to multiply this top equation by 4, and I'm going to multiply the bottom equation by 3. Now you do have to be very careful that you multiply the entire equation, okay? Not just the left-hand side, not just the term with the y, but every single piece of it, okay? If you don't do that, then you're actually changing the equation. All right, so when we do that here, we're going to get 20x plus 12y is equal to 36. And down here, we will get 6x minus 12y is equal to 42. All right, so now when we go ahead and add these, just like what we wanted, the y's will cancel. All right, so now we have 26x is equal to 78. All right, so now we divide both sides by 26. All right, and x is equal to, I believe that is 3. All right, so again, now we can pick either of the original equations. It really doesn't matter which. I'll go ahead and pick this bottom one just because it has a smaller coefficient of x, but again, it doesn't really matter which. So I'll say 2 times 3 minus 4y is equal to 14. 2 times 3 is 6, so if I subtract 6 from both sides, we get negative 4y is equal to 8. All right, so y is equal to negative 2. So we know that these equations would intersect at 3, negative 2. All right, so let's go ahead and take a look at this one. All right, again, it doesn't matter which variable we're going to eliminate. I can notice very easily that if I multiply this top equation by 2, that I'll have opposite leading coefficients. So when I do that, here I'm going to have 2x minus 4y is equal to 6. And I didn't change this one at all, so negative 2x plus 4y is equal to 1. So when I go ahead and add these, well, these cancel and these cancel, so that's just 0 is equal to 7. Well, hopefully we're smart enough to know that 0 never equals 7, so that tells us that there is no solution. And that just means that if you were to graph these things, that they would never intersect. Well, and when we're talking about lines that never intersect, we're talking about them being parallel lines. So these things would just be parallel lines. All right, similar here. All right, I can go ahead and multiply this top equation by negative 2. That'll give me a negative 4x and a positive 4x. So here I get negative 4x plus 2y is equal to negative 2. I didn't change this one, so 4x minus 2y is equal to 2. All right, when I add these things, well, this cancels and this cancels again, giving me 0. Well, negative 2 plus 2, those also cancel to 0. All right, now 0 equals 0 is true. All right, so that actually tells us that there are infinite solutions. All right, so there's kind of 3 different cases, and we've seen them all so far. All right, most of the time there's just one solution, right, and that's when you can just solve it and you get an x and you get a y. All right, now of course this is with linears. If you throw in quadratics or something, you could have a couple of solutions. All right, but when we're talking about linear functions, all right, you can either have one solution, no solutions, or infinite solutions. All right, obviously we can skip that. Your homework is going to be on Delta Math, so we are good to go. Does anybody have any questions